there, guys. Welcome to another day of doing NeetCode. Today we're gonna be continuing on. I'm feeling pretty good about binary search, and we're gonna be doing the continuation of the one we did yesterday of minimum. We'll be doing search in rotated sorted array. This one is very similar. We just have to oh, if number, it's doesn't seem too bad. We should return the index. Should be. I think we'll be able to do this. It doesn't seem like too difficult. It's just a binary search, except we have to find, this time we have to find a target. We're given a target number, we have to get the index of that target, and if that doesn't exist, we just return -1. So by default, what we'll do is we'll go LR equals 0 when nums -1 res equals -1, so that if we don't find anything, it will go here, and then we'll say, okay, so while L is less than R, oh, of course, it didn't happen yesterday, but it happens today, of course. While L is less than R, what we want to do is we want to look at the left and we want to get the middle, right? So the middle is going to be the same thing we did over here, as always. And then the middle integer, we're going to see, okay, well, it's same thing as before. If nums at mid equals target, res equals target break, and then else, right? So in a different else statement, we're gonna do the barriers, right? So it's gonna be probably the same thing. If we have what, 3, 4, 5, 6, 1, 2, and we're searching for 1, we're gonna look at this R over here and L over here. Mid is gonna be like, I think it's this one, and we know that it's gonna be yeah, we have to find a way to ask if it's, because we know it can't be between 3 and 5, right? Because the only number between that is 4. And then we have to ask, okay, so it has to be between 5 and 2, which makes sense, right? So we have to find a way to like look at that. So what I'm suggesting is we gotta look at all the numbers. Ooh. It's hard. So now we actually have to think about how we're gonna look at it. Before we did the thing where we took the lowest one, right? And that was pretty easy. But this one, we need an actual target. So I don't need to do this. Return res equals yeah, okay. No, it'll definitely find. Actually, no, it won't find it. could do it if, and then just have that. But that's, yeah. So what we're gonna do. Yeah, we need a way to find it, right? So it's in 356012, right? Or 3345612. I'm looking for one. We're going between 5 and 2 right now. Say okay. Which one's closer, I guess? Well, I guess it depends, because you know, right? Like if you look at if the number's 1, right? 2 is closer to it. Oh, but it could be over. Like if the number was 1, if it was 1 and 0, if it was, thinking of an example, if it was 2, 3, 4, 5, 1, oh, 1. Ooh, it would never be 1, 0. But if we're searching for O here, whichever number's closer. So if I say, okay, the closer one becomes that, so we'll look at if absolute nums at R minus nums at mid is less than absolute nums L minus nums at mid, then what? So if let's look at it, right? So if nums at R is less, then right side is closer. R mid left, so left is going to become mid, so L equals mid plus 1, else R equals mid minus 1. You think this is going to work? Oh, so it worked in one case. Okay, it worked in one case. Oh, that's because it worked on the -1, but it didn't work here. Output was -1, and we did not check that. Let's look at the solution on the last one, because they the way they found they did min current. Yeah, no, never mind. It's not what I wanted. But I think it's the way I'm doing this. If I run this, it's just never going into this res equals mid thing. Yeah. Okay, so let's look at why our code is doing this. So we'll create a thing. Actually, we'll go paint. We'll go MS Paint. Right. So we have 3 4 5 6 1 2. 3 4 5 6 1 2. All right. This is our R. This is our L. Our L is gonna be 0 plus 5 plus 4 divided by 2, so 2. So our mid's gonna be here, and we're gonna say okay. Absolute. So nums at right. Oh. No, not nums at mid. Minus target. Okay, so there you go. Please work. Wrong answer. Okay. Expected output was 0. I just delete this and I run it. Is it gonna work? No, out of. Ooh, wow. Update and recovery. Cool. Yeah, but if I have like this and this, it's gonna say no because L is not less than or equals might work. No, this one also. Oh wait. Well, L is less than or equals to R. They're both equal to 0. Mid gets 0 plus 0 minus 1 divided by 2. It's just going to be 1 or negative 1. And then I'm going to say if num's at negative 1 equals target, which it does. Whoa. And I have 1 less than or equal to 0. Or... Huh? Oh, because I'm going index negative 1. So I think what we do is if mid equals negative 1, res equals 0. Else... This work? Okay, submit. Wrong answer again. Oh, this is being too complicated. Okay, so we're gonna take these two test cases. We have a 3 and we have a 1 and 3. These are the 3 test cases that are bugging us right now. So we're gonna try this, and we're gonna try this. See what happens. Okay. We're gonna take up all this again, and we're gonna try it with this. Okay. Okay. And then okay, so I have all 4 test cases. Rate limit, that's fine. That's not a real error. Rate, okay. Take a 10-second breather. It's the code. Pray it works. Let's go. Okay. It took us 13 minutes. Listen, all we have to do is remove the negative 1 here. I put it here so that, honestly, it doesn't matter though. I just did it because that's what I did over here. And I did this one because that's what I did in another problem. But I feel pretty good about binary search. There's only, I think, 2 more. So time-based key value and median of 2 sorted arrays, which we'll do tomorrow and the day after. And then we'll probably return to stack, even though I don't like stack. But, yeah. See you tomorrow.